Okay, welcome back once again to all my dear students. Today we are going to discuss about the valence band theory. But before starting that, let us revise the topic which we had discussed in the last video. That is a polarity of bond. As we had discussed that none of the above bond is completely ionic or completely covalent. As for example, we have taken that H2Cl2O2. By sharing one electron, it can form a bond. But when we are going to discuss about the bond length and bond enthalpy, we can say that there is some ionic character will be there, right? As for example, we have taken hydrogen fluoride, in which the electronegativity of the fluorine atom will be more, and that's why it carries a partial negative charge and hydrogen carries a partial positive charge. And whatever the bond is there between the hydrogen fluoride, then becomes a polar. And as the bond is polar, then you can get the dipole moment. See, the dipole moment that is directly proportional to the electronegativity, difference in the electronegativity. If the difference between the two atoms of electronegativity will be more, then we can say that the dipole moment will be more. Understand? As for example, we have also discussed about the water molecules, right? But in BeF2, beryllium is a central atom, and around that, two fluorine atom is there on the opposite direction. So that it will be nullify the effect of dipole, right? And that's why we can say that in BeF2 the dipole moment will be 0. Understand why? Because it is the opposite direction. So it will be nullify the effect of dipole moment, right? Then after we have discussed next point, that is let us suppose here the dipole moment, when we are going to discuss about the dipole moment, then NH3 and NF3, that NF3 will have the less dipole moment as compared to that of NH3. Why? Even if the fluorine is more electronegative, then also we can say that the dipole moment of NH3 will be more than that of NF3, because in NH3, 3 hydrogen atom will donate the electron towards the nitrogen, only one nitrogen atom. Whereas in the NF3, nitrogen atom will donate the electron towards the 3 fluorine atom, right? So there is a distribution of the electron will be take place, whereas here in NH3, only on one atom the density of the electron will be more. And that's why we can say that there is a more electronegativity, difference in the electronegativity in NH3 as compared to that of NF3. And that's why we can say that NH3, the dipole moment will be more as compared to that of NF3, right? Then after we have also discussed certain that observation table types of molecules, that is AB, AB2, AB3 and AB4, and then geometrical shape is there and dipole moment is also there, right? The things that you have to remember, that which one has a zero dipole moment, that's just like a BeF2, BeCl2, CO2, right? H2, all this will have the dipole moment 0. Is it clear? Now let us start the next topic, that is the valence band theory. चलो आज हम देखते हैं valence band theory. Valence band theory. Okay. First of all, you have to know that who will present the valence band theory. So Hitler and London presented the valence band theory. Hitler and London presented valence band theory, VBT. Understand, right? And Linus Pauling as well as the Slater has developed this theory, valence band theory, right? What is there in the valence band theory? According to this theory, when the half-filled atomic orbitals are come close to each other, then the orbital will be overlapped and forms a bond. That bond is said to be the covalent bond. Once again, कोई भी ऑर्बिटल हाफ फील्ड है और वो ऑर्बिटल एक दूसरे के नजदीक आती है, तो क्या होता है कि उसके बीच में ओवरलैपिंग होता है, और ओवरलैपिंग से जो बॉन्ड बनता है उसको हम बोलते हैं कोवेलेंट बॉन्ड. So that is this theory. According to this theory, I can write down. According to this theory, what is that? That when half-filled atomic orbital come near to each other, when half-filled atomic orbital come near to each other, then what happens? then they got overlap. Then they got overlap. And as a result, the formation of covalent bond is thus the covalent bond is formed. Right? When the orbitals are overlap, when they are come close to each other, they become overlap, and then whatever the bond it can form, that bond is said to be the covalent bond. यह हमको मालूम होना चाहिए, राइट? जो भी बॉन्ड बनता है उसको हम क्या बोलते हैं? कोवेलेंट बॉन्ड, राइट? We can also say thus combining atoms share their valence electron and forms a covalent bond. Yes, can say thus combining atoms share their valence electron and forms a covalent bond. Share their valence electron and forms covalent bond. Understand? Is it clear? Sometime out of two combining atoms, we can say sometime out of two combining atom, we can say that the orbital of one atom may be completely filled. The orbital of one atom may be completely filled, and the orbital of another atom and the orbital of other atom may be vacant, and the orbital of other atom may be vacant, right? Then whatever then they both overlap and form special type of covalent bond. Then they both overlap and form special type of covalent bond. Understand? Is it clear? They overlap and forms a special type of covalent bond, which is called coordinate covalent bond. That is coordinate covalent bond. Understand, beta? So all these things you have to know. This is the basic concept. Now let us take the two atoms. If I take the two atoms just like atom A and B of hydrogen which possess nuclei. Take two atoms of hydrogen which possess nuclei Na and Nb, right? Na and Nb, and electron of two atoms and electron Ea and Eb, right? Two atoms are there in which the nuclei is Na and Nb and electron is Ea and Eb. When these two atoms are far distance, there is no attraction and repulsion force between them, right? When these two atoms are far away from each other, there is no attraction and repulsion force. There is no attraction and repulsion between nucleus and electron, right? But when they come nearer to each other, when they come nearer to each other. Now what happen when they come nearer to each other? क्या होगा कि जब वो एक दूसरे के नजदीक आएंगे, then the attractive and the repulsive force produced between them, right? Then the attraction and repulsion force, attraction and repulsion force produced between them, right? Between them. Now, first of all, let us write down attraction force, right? तो attraction force किसके बीच में आएगी? तो न्यूक्लियस और इलेक्ट्रॉन के बीच. तो let us start. First of all, attraction force. तो पहला पॉइंट, चलो. तो the attraction force produced between nucleus of atom itself. The attraction force produced between nucleus and electron of atom itself. Between nucleus and electron of atom itself, right? As for example, क्या आएगा यहाँ पे? तो NaEA के बीच और NbEb के बीच, right? Now the attraction force produced by the nucleus of one atom and electron of the another atom. The attraction force produced by the nucleus of one atom and electron of other atom, right? यहाँ पे क्या आएगा? NaEb and NbEa. Is it clear? Now let us write down repulsion force. What is that? Between the nucleus there is a repulsion, is that? So in the same way we can say repulsive force produced between electron of two atoms. Repulsive force produced between electron of two atoms, that we can say Ea and Eb. And repulsive force produced between nucleus of two atoms. So repulsive force produced between what? Nucleus of two atoms, that we can say Na and Nb. You all know that between electron and nucleus there is an attraction is there, whereas between nucleus and electron there is a repulsion. So these are the attraction and the repulsion force which can be produced when the two atoms are come close to each other. Understand? So write down all these things. Okay, now next one. See here, as there is a repulsion and attraction force is there, so I can also write down. Let us suppose here is a Ea and here also Ea or Eu. Here it is a Na and here Nb, right? So between here Na and Ea, this is the old force, attraction force. This is also called attraction force. जब दो एटम when they are far away from each other, so this attraction force is said to be the old force. इसको क्या बोलते हैं हम? old force. old force. अब जब दो एटम एक दूसरे के नजदीक आते हैं तो न्यू फोर्स, नया फोर्स आएगा. तो ये जो है ना, ये नया फोर्स. Between this we can say new force. Understand? Force. Is it clear? So this we can say attractive force. यहाँ पे मैं लिखता हूँ attractive force. Right? Now repulsive force. Let us see. यहाँ पे एक Na Nb. Right? यहाँ पे मैं लिखता हूँ Na और यहाँ पे Nb. यहाँ पे Ea. ये देखो. और यहाँ से Eb. चलो Ea और Eb. So this we can say it as a repulsive force. Second, repulsive force. ये attractive और ये repulsive. Means between two electron and two nucleus there is a repulsion is there. Right? So these things you have to know. But the most important thing it is true experimentally that magnitude of attractive force is more than that of repulsive force. So I can write down here, but it is proved experimentally that the magnitude of attractive force is more than that of repulsive force. Of attractive force is more than that of repulsive force. Understand? Is it clear? Now, next one we can say that as a result, both the atoms are goes close nearer to each other, right? So as a result, both atoms go near to each other, and the potential energy is decreased, decrease. Right? When the two atoms are come close to each other, its potential energy will be decreased. Up to how much extent it will become close to each other? Until the attraction force is neutralize the repulsion force. Right? Up to that much extent it will become close to each other. Right? So I can write down here. चलो एक बार लिखता हूं कि up to how much extent it will come close to each other. So I can say that both the atoms go near to each other to such an extent that attractive force balanced by the repulsive force. Both the atoms go near to each other up to some extent that attractive force balance the repulsive force, right? That attractive force is balanced by the repulsive force. That attractive force balance the repulsive force. Right, and thus the potential energy will becomes zero. Understand? And the system attain minimum energy. And the system attain minimum energy, and the system attain minimum energy. Right? Is it clear? As for example, let us suppose if I take the hydrogen atom. Let us suppose if I take hydrogen एटम। चलो मैं हाइड्रोजन एटम लेता हूँ। तो आपको मालूम है कि अगर हाइड्रोजन एटम इज H2 है, two hydrogen atom is there. So here this is one hydrogen atom and this is second hydrogen atom, right? So between these two nucleus is there, it come close to each other. दोनों atom एक दूसरे के नजदीक आते हैं, पर up to how much extent that it will balance the repulsion force. Attraction force balance the repulsion force, and here the that length is said to be the bond length, and it will be equals to 74 picometer. Understand? So this is the bond length of the two hydrogen atom. Is it clear? In H2 molecules, in H2 molecules, right? Is it clear? So this is all about the valence band theory. Once again, I will explain you the valence band theory what we have discussed. First point, that who will present the valence band theory. So Hitler and London has presented the valence band theory, and who will develop it? So Linus Pauling and Slater, right? Second point, that when the half-filled atomic orbital are come close to each other, then it will be overlapped and forms a covalent bond, right? See, one thing is that sometimes the orbitals of one atom is completely filled, whereas the other is vacant. At that time, whatever the overlapping will be take place and whatever the bond is formed, that one is said to be the specific covalent bond. The another name we can also say is a coordinate covalent bond also, right? So that we have discussed, that is all about the valence band theory. Then we take the example just like a hydrogen atom is there, in which two atom A and B. A atom the nucleus is Na, B atom nucleus is Nb, electron Ea, electron Eb. So there is the attraction and the repulsion force is there, right? So attractive force between the same molecules, between the different molecules, repulsive force is there between the nucleus and between the electron. That we have discussed. And then the most important point that we have discussed, that the attraction force is the magnitude of the attraction force will be more than that of repulsion force. So that's why we can say that the atoms are come close to each other up to such extent in which its potential energy will becomes minimum, and we can say that the attractive force is balanced by the repulsive force. Understand? So up to that much extent it will come close to each other. As for example, see here, if we take the hydrogen molecules in which the two hydrogen atom will be there, and between the two nucleus, what up to this much extent it will become close to each other. So that whatever the distance is there, that distance is, we can say, is a bond length, right? Note down. Now, next point, there is the assumption of valence band theory. Assumption of valence band theory. Assumption of valence band theory. Assumption of valence band theory, VBT. Right? What is assumption? First one, we can say that the strength of the covalent bond is directly proportional to the overlapping of an orbital. So I can write down the strength of covalent bond is directly proportional to the magnitude of overlapping orbital. The magnitude of overlapping orbital of two atoms, right? Orbital. Magnitude of overlapping of orbital of an atom, right? Second, here we can say that what this statement indicates, that if the overlapping will be more, then the bond is become strong, right? Whatever the covalent bond is formed by the overlapping of orbital, it will be strong, right? So second, we can say generally there must not be much difference in the energy. Generally there must not be more difference, not be much difference in the energy of an orbital, in the energy of overlapping atomic orbital, energy of overlapping atomic orbital means whenever there is a overlapping between the two orbitals, then there is both the atom will have the same energy, both atomic orbital will have the same energy, or less difference is there, then only it will be overlap and forms a covalent bond, right? So this is the second point. Third point he says that the overlapping orbital must have half field, right? The overlapping orbital must be half filled, and the spin of the electron must be half filled, and we can also say the spin of electron in them must be opposite direction, and spin of what electron in them must be in opposite direction, right? Spin कैसी होनी चाहिए? Both electron it will be opposite to each other. And the last point that we can say, there must be overlapping of orbital so the chemical bond will be formed. In such an extent, the overlapping will be take place in such a way that it can form a chemical bond. तो उसी extent से overlapping होनी चाहिए, so that it can form a chemical bond, right? So last point, there must be overlapping of atomic orbital to proper extent of atomic orbital to proper extent that you can say so that chemical bond is formed, right? So all these are the four different assumptions of valence band theory. First one, he says that here the strength of the covalent bond is directly proportional to the overlapping of an atomic orbital. Second point, that there is a less difference in the energy between the two orbitals which can be overlapped. Third point, half-field orbital and the spin will be opposite. And last point that we can say that there must be overlapping of orbital up to some extent so that it can form a chemical bond, right? So all this we have discussed today, that is the valence band theory. Okay, now tomorrow we are going to discuss about that overlapping atomic orbital, that is how the overlapping will be take place. There is a positive overlapping is there, negative overlapping is there, zero overlapping is there. Then how they can form the sigma bond and pi bond? Which orbital will be overlapped? S and P orbitals, right? So how the overlapping will be take place, that we have to discuss in the next video, right? So in this video up to here it's enough. So thank you very much.